Hello everyone, this is Group 5. In this video, we're going to present our proposal, which is improving the efficiency of fire inspections by proposing a fire risk leveling resulting from the impact of independent variables on the probability and severity of residential incidents. So according to NEPA, the number of residential fire, property, and human losses has been increased over the year. So what if we make the inspection as a smarter service? Instead of adding resources for inspections, can we allocate the existing one in a more efficient way? So here is the list of objectives divided into two parts: fire probability and severity.
Our process in a chunk following the CRISP-DM steps includes comprehending the cycle of fire prevention management and its contribution to decrease fire losses, understanding and preparing datasets, analyzing and modeling, including data reduction, finding out average fire frequency, obtaining frequent fire scenarios, predicting fire incident probability and its severity. The first objective, which is understanding the datasets and preparing it for the next steps, including data preparation, creating the labeled feature named as fire incident occurrence with yes/no value, categorizing the string data, which allows us to focus on the fire incidents among all other incidents, and the output would be EDA, annual average fire frequency, and the labeled dataset. Predicting fire incident occurrence and probability would be obtained using the merged fire incident dataset with inspection and violation, creating the model for prediction for occurrence and its probability using algorithms that are more suitable for mixed datasets and provide with frequent scenarios. The model will be evaluated not only based on accuracy, but also based on recall and precision, which matters in this context and result in saving more resources.
The next step is severity. For this, we have to normalize the numerical data we have, then cluster them using k-means. The output cluster will be labeled. Then we'll train a model using kn or dt to predict severity levels. Also, we'll evaluate the performance of our model through cross-validation, thus obtaining accurate severity levels. The final step is to combine the probability and severity models through k-means or db to define ranges and plot them together to make a risk level matrix. This risk level will help prioritize future fire inspections. Now we take a look at the list of datasets that we are using. They are all from the same source, the San Francisco Open Data Catalog.
Let's now take a look at some data assessments and visualizations. It is important to note that the data we're looking at ranges from 2003 to 2022. In the first image, we're looking at the incident count per neighborhood, where two clear regions have over 1,300 incidents each. When the alarm goes off and the fire department is dispatched, this does not qualify as a fire incident. Actually, over 80% of the cases did not qualify. This can also be seen in the clustered graph on the right. When the fire department arrives, this value is represented by the large number of investigations taken as primary action. These investigations can be either caused by smoke, kitchen, or electrical sources. The same seems apparent when looking at the incident count versus the primary situation. Finally, we'll look at the distribution of incident counts based on property use, where 1 to 2 family or even multi-family dwellings are more occurrent.
Our dataset for San Francisco buildings contains 223,000 residential buildings, while the incident dataset shows 200,000 records. We were able to match 170,000 of incidents with the buildings. By identifying the incident happened in same buildings, we noticed that incident records are distributed among 17,000 buildings. 40% of those incidents were not related to our investigation, 40% were false alarm, and less than 20% were fire incidents. Our next step of this project will be matching other datasets with merged addresses and incident files, finding out fire scenario frequency, training and validating the model for predicting probability of fire incident, clustering data points and certain attributes for fire incident severity, classifying fire incident severity, and providing fire incident frequency consequence metrics. Thank you.